the fatigue of the spatula you use in the kitchen. If you use it for 1 million times, it may fail. So it's like, because you may use it every day, in the morning, in the afternoon. So after, say, 1 year, 10 years, it's been used for millions of times. Then what will happen to the spatula? It will be interesting for us to know. Next page, please. Okay, when we use the spatula, we heat it while frying pan a lot of times. Also, the temperature is going high and low. So the temperature increase will create thermal stress inside. Like now it's very cold. So we will create stress inside our body because if you are hot, you are going to expand. If you are cold, you are going to shrink. This expand, shrink cycle will create stress inside your body. And another example for this figure is like, so pay attention to me, please, everyone. Here, I'll stand here. Okay, everyone. Like, this is my spatula. I just want to cook. I just use the spatula to cook. Then, like, if I say bend this one, then I just keep using it. We have initial stress, then we increase, decrease, increase, decrease. So we have some initial stress already, and we increase the stress, decrease the stress, increase, decrease. So this figure is like we have the curve, and the curve shows that if this one is at the middle, we go up, go down, go up, go down. It's just like the case here. The average is 0, and we increase, decrease, increase, decrease. But if we have some initial stress, we increase, decrease, increase, decrease. The case looks like this. We have some initial average stress, then we increase, decrease, increase, decrease. So these are the different scenarios we encountered in engineering problems. Next page, please. So we do some tests, like this one. We have some tension already. Then we increase, decrease, increase, decrease the stress. Like we have some tension, then we increase, then decrease, increase, decrease. So this is one scenario. Another scenario is we do compression. Then we do some compression, like compression, then increase, decrease, increase, decrease. But we have some initial compression here. So we increase, decrease, increase, decrease the stress. So what will happen for these two scenarios? Next page. Before we jump into that two scenarios, we show you one figure. The y coordinate is the stress. The x coordinate is the cycle we applied. So we do some testing. If we apply a stress up and down at this level for this material, this steel material, Then until we break the material, we count how many cycles we break it. Then we have one testing point. Then we test in another stress level. We do the testing. So until this cycles, 10 to 6, it breaks. Then we just decrease the stress. Then we do the testing. So it may go to 10 to 8 times cycles to break. So we have this stress cycle curve. So this figure will tell us what's the safety stress we can apply. Then the special will last for a long, long time. So let me ask you, yes. So if we design some tool to use, then we like there's a label on the product. You will tell your customer, under this stress label, you can use this tool for 10 to 6 times, then it will break. But you can also tell your customer, if you apply stress lower than this level, you can use your tool forever. It's pretty safe. For your lifetime, probably it won't break. So do you follow this stress cycle curve idea? Pretty good. We call this SN fatigue. S means stress, N means cycles. Okay? Do you follow me? Pretty good. So we have the aluminum material. The stress strain cycle follows the rate curve. Different materials have different SN curves. So they are useful for designers to design their product. Okay. Stress and cycles. It doesn't matter to which tool you apply. You can apply this data to your bike. You can apply this data to the car, because what we care is the stress data and cycle, the stress. So different objects, different tools, we can calculate the stress, the maximum stress, the stress variation, and apply this curve to the product you are interested in. It can be your cell phone. It can be your, come in please. It can be your your bottle. Any product you can apply. What matters is the material of your product. Like the bike might be aluminum. Then the electric car might also be aluminum. So if they are aluminum, then we can apply the stress strain data for aluminum to your product. Next page, please. Okay. The R value. When we apply this SN curve, we want to know the cycle of stress. We have maximum stress and minimum stress. The minimum stress value divided by the maximum stress value is the R value. So we have R equal minus 1 means the minimum divided by the maximum equal to minus 1. So it means they are in opposite sign, but the same magnitude. Like the green line, the green curve here. Okay, next page, please. Okay, a quiz for this SN curve, for this trace cycle. What's the R value for this one? The R value equal to the minimum stress divided by the maximum stress. So just look at the value. So, okay, what's the R value for this case? 0. Okay, correct. Because the minimum stress is 0. The maximum stress is, it has some positive value. So 0 divided by some positive value should be 0. Okay, so do you get it? Okay, next page, please. Then, because when we do SN curve, we always try the case. We did the experiment for R equal to -1 because we cannot test too many cases. So usually we as an engineer, we just test the R equal to -1 usually. But in our life, the mean stress might not be 0. The mean stress could be some positive value or some negative value. Okay, next page, please. So this is the SN curve, a typical one. Okay, next page. Then, if the mean stress is like -5, or the mean, if the we have compression mean stress or tension mean stress, and the 0 mean stress case. The 0 mean stress case is the green line. The compression mean stress is the yellow line. The tension mean stress SN curve is the pink line. So let me ask, for the same stress, like, okay, look at me, please. For the same stress here, which one has a longer life? For this stress level, the yellow one, the green one, or the pink one? The yellow one has longer life. So means compression mean stress, we can have longer life for our product. So material prefer compression. Material doesn't like tension. Under tension, the life of the product will be shorter, usually. Okay, next page, please. Okay. So these two cases, the case on the left and the case on the right, in terms of SN fatigue data, they are equivalent. For, say, if you have some positive mean stress, you can convert the case with positive mean stress to the case with 0 mean stress. They will have the same life cycles to failure. So for the case with tension, when we convert the case with tension to the case with 0 mean stress, the force magnitude will become larger. Just some mean stress correction case. So do you follow this one? Okay, next page, please. Now, comes to our SolidWorks simulation. The SolidWorks simulation can tell you the information about the repeated use of your product. Previously, we modeled our target just like 1/4 cycle. But now we want to see what will happen if the product is under repeated loading, the repeated cycle of forces. Okay, next page, please. So the same, we have the spatula. So like we use the spatula every day, so once or twice or 3 times. Because under one cooking cycle, you may use the spatula many times to flip the food to like a lot of times. So if every cook you use the spatula for say 50 times, then after 1 year, it will be thousands of times of use of the spatula. So will the spatula fail under completed use of the cooking cycle? Let's see what happens using the SolidWorks. Okay, next page, please. Okay, we do new analysis, fatigue testing. Next page. Say the amplitude of the load is 100,000 Newton. So let's put the static load is 100,000. Okay, next page, please. Then also the thermal loading event. Because when we use the spatula for cooking, we apply force to the spatula, but also our pan is heated, so we have thermal stress applied to the spatula. So not only we apply force to the spatula, but also the temperature of the spatula is going to be increased. So we have thermal stress layer 2. So we add another event, the thermal stress event. So the thermal stress is also 100,000 Newton, or the load 100,000 Newton due to the heat, the temperature. Okay, so we have 2 events occur during the cooking. Okay, next page. And we want to add the material SN data. So this data is in the database for different material. So we select the material, the SN curve data. See, it depends on which material you used for your product. You have different SN curve to select. Next page, please. Okay, this is the SN curve data. So N is in the second column. S is in the third column. It's in the database. We just select it. Or if you have your own SN curve, you can create your own SN curve for your design. Next page, please. Okay, then we define the interaction of our loading due to we apply the force, or the loading due to temperature. So we have 2 cases interaction: thermal stress and the usual stress due to you apply force to the spatula. Okay, so next page, please. Then we did the random interaction for the thermal stress and the stress due to the force you applied. Okay, so next page, please. So we run the simulation, and the result is, say, percentage of damage due to fatigue. So the red spot represents the highest percentage. It's very small, 0.2% of damage. Means your design under this repeated loading due to temperature increase and due to you apply the load to the spatula, only 0.2% probability to damage your spatula. So as a mechanical or as a design product engineer, you are pretty happy with the product. Or if you are not an engineer, but you are in the design team, you are an accountant, you enjoy the design meeting. When the mechanical engineer presents you this testing result, probably you have some idea what's going on in the mechanical engineer design process. So what's your major?
Agribusiness.
Agribusiness.
Business.
Business.
Yeah.
So you have a good purpose to be here. As a business manager, you would like to know some product aspect from the engineering department. Okay, so I'm happy you are here. So do you follow today's lecture? What is fatigue? What is fatigue testing? Okay, so do you know what SN curve is? SN curve. What is S? What does S stand for?
S?
Yeah. Stress. What does N stand for? Cycle to failure. Cycle. Okay, so let me ask you again. What does N stand for? Cycle to failure. That is N. And S. What does S stand for? Yes, good. Thank you. Okay, next page, please. Could you read the first point?
Damage below 100% shows the design will last more than the number of circles specified in the setup.
Okay, could you read the second point?
A damage percentage above 100% indicates the design will last less than the number of cycles specified in the setup.
Okay. Lady, could you read the third point?
If you receive a warning indicating the alternating stresses are too low, or the damage cloud is only 50% and the life expectancy is 1 million, the design has a high factor of safety and the design has met its endurance limit and will not fail.
Okay. Pretty good. If the message just says the alternate stress are too low, so you are pretty happy, because the message tells you the product won't fail. Or the damage percentage, the probability is less than 100%, because 50% is less than 100%. Then your product will not fail under the specified number of cycles. But if the damage percentage is less than 50%, probably your product can last forever. Okay. All right. Any question, young man?
No.
Okay. So next page, please. So you can go to the YouTube to watch some video for something related to fatigue testing. But also I posted the simulation video on YouTube. You could go to iLearning to follow the link to the YouTube. From the YouTube for today's SolidWorks simulation. Okay, so pretty much that's what the lecture will be today. Okay, cameraman, could you turn off the camera?